and welcome back to Chapter 4. We're going to continue our trigonometry journey. Today we're going to cover, or this video covers, right triangle trigonometry, which is one of my personal favorites. It's really cool because using right triangles is another way to explain the ratios and find the values of the trig functions. And also, we can actually use a right triangle trigonometry to help us explain the unit circle. And that will be something that maybe we can talk about during an office hour, because I'd really like to show you that as well. Okay, so what are we doing today? What's our goal? We're going to evaluate trig functions of acute angles that are less than 90 degrees or less than pi over 2. We're going to use a calculator. We're going to use the fundamental trig identities, and then we're going to use trig functions to model and solve real-life problems. Okay, so again, this is introducing the 6 trig functions from a right triangle perspective, which is really cool. So let's consider a right triangle. Okay, so let's say here you have the acute angle labeled theta. If you look at the angle theta down there, you see that there's 2 sides and then there's a hypotenuse, right? We always call the longest side the hypotenuse. The hypotenuse is the side that's opposite the right triangle, yeah? So hypotenuse is always hypotenuse. It never changes when you have a right triangle. But the 2 sides can be called different depending on where theta is. So let's say, for instance, the bottom side is the side that's adjacent. We use the word adjacent to describe that side because it's touching theta, or it's next to theta. It's literally adjacent to theta, okay? Now, the other side is the side opposite theta. It's not touching it, okay? So we would call this adjacent and opposite. All right, so relative to whatever theta is, the 3 sides of the triangle, we call them hypotenuse, the opposite side, and the adjacent side. So now, see how we have the 3 sides? We form 6 ratios, okay? We have sine of theta is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, and then cosecant is just the reciprocal of sine. Secant, again, look, it's the reciprocal of cosine, and cotangent is the reciprocal of tangent, yeah? So one way to remember, so if you know the first 3, you actually know all 6. Sometimes we use the acronym SOHCAHTOA because it's SOHCAHTOA, because sine is opposite over hypotenuse, so that's the SOH part, and then cosine is adjacent over hypotenuse, CAH, and then tangent is opposite over adjacent. And then the other 3 are just the reciprocal, Okay, so basically we're going to define this for theta defined as an acute angle, okay, of a right triangle. So of course it's going to be acute. If it's not the right angle, it's those 2 other angles are less than 90. So here are the 6 trig functions, and so basically like we said, so we're opposite, adjacent, and hypotenuse just means the side opposite. Adjacent is the side adjacent, and HYP is the hypotenuse, which is pretty straightforward, right? So if we use this triangle here, so suppose you have a triangle with a hypotenuse, theta, and then we have a side of 3 and a side of 4. You can use the Pythagorean theorem to find the hypotenuse, right? So using the Pythagorean theorem, we do 3 squared plus 4 squared, and then we add them and we square root that because we're solving for hypotenuse. So that would give us 5. This is actually a 3, 4, 5 triangle. It's a very popular triangle. So if I know what the opposite side and the adjacent side is, if I were you, maybe take a little screenshot of this and then compare it to the next slide, because I did not put it there, sorry. So you can see for yourself, okay, relative to theta, the sine of theta is going to be opposite over hypotenuse, so 4/5, adjacent over hypotenuse, 3/5, opposite over adjacent, 4/3, and then cosecant is the reciprocal, hypotenuse over opposite. Secant is the reciprocal of cosine, so 5/3, and cotangent, the reciprocal of the tangent, which is 3/4. Okay. So in that example, we were given the sides, but not the actual angle. And sometimes, a lot of times we'll be asked to find the trig functions of an angle. So the way that we do this, we construct a right triangle using theta as one of its angles. So we have here sine of 30 would be sine of pi over 6, which is 1 over 2. A 45-45 triangle is it's saying sine of pi over 4, you would get root 2 over 2, and so on. These are very common. And I can show you, you need to know the special right triangles, and I will talk about that again. But yeah, so these are the ones that you need to commit to memory. Okay, so another thing we can say is the cofunctions. So we say, notice that you have here sine of 30 is equal to 1/2, which is the same as cosine of 60. This is because 30 and 60 are complementary, okay? So cofunctions of complementary angles are equal. Okay, so what does that mean? That means that if you have the sine of an angle that's complementary to theta, that sine of that angle is going to be equal to cosine of the original angle. So let's say you have cosine of 60, 90 minus 60 would be 30, so sine of 30 is going to be equal to cosine of 60. Okay, similarly for tangent and cotangent, you have, let's say you had cotangent of 30, that would equal tangent of 60, and so on. So notice that they all have their corresponding, this is sine, cosine, tangent, cotangent, secant, cosecant, and vice versa. So those are their cofunctions. Okay, now let's get into trig identities. So trigonometric identities. Let's look at the reciprocal identities, and we've already been kind of talking about them, okay? So sine, we know that sine and cosecant have the reciprocal relationship. So does cosine and secant, tangent and cotangent, and vice versa, right? If you have one, you know you'll have the other by writing it as a reciprocal, okay? So you really only need to find 3 of the functions values to find all 6. Here's some other identities. Tangent of theta is equal to sine over cosine, and therefore cotangent of theta will be equal to, since it's the reciprocal of tangent, cosine over sine. Okay, also notice we have what we call Pythagorean identities. And this comes from the unit circle also, but you don't need to know that. I mean, just if you were curious why, like it comes from that, it can be derived from that. So the relationship is this. Remember that sine of theta or sine of t is y and cosine is x on the unit circle. So x squared plus y squared is going to equal 1. Okay, so this is kind of like the main one, the top one. The others you can derive. Like for instance, if I divided everything here by sine, I would get 1 plus cotangent squared theta is equal to 1 over sine, which is cosecant squared theta. Okay, so as long as you know the first one, you can figure out the other 2 by dividing by sine or cosine squared. Remember that sine squared of theta, or at least make sure that you know this little 2 right here, what that means is sine of theta squared, okay? It's like shorthand way of writing squared. Okay, so let's use some. So let's let theta be an acute angle, so less than 90, such that sine of theta is equal to 0.6. So can we find cosine of theta and tangent of theta using trig identities? And we can. Because we know what cosine theta is, we can use the identity sine squared plus cosine squared is equal to 1 and just plug it in. Okay, so we plug it in, we have 0.6 squared is equal to cosine squared is equal to 1. Then we subtract that from each side, and we get cosine squared is equal to 0.64, right? Because 0.6 squared is 36, 0.36. 1 minus 0.36 will be 0.64. And then, of course, the next thing you would do, we know it would be to take the square root of both sides, right? Or so then you would have cosine of theta is equal to the square root of 0.64, which is 0.8. So now that we know what sine of theta and cosine of theta is, we can easily find tangent, yeah? And tangent of theta is just y over x, right? So that's 0.75. So see here, here's a triangle. So you have theta, tangent would be 0.6 over 0.8, and that's 0.75, okay? All right. So finally, some applications. So the applications that involve right triangle are very fun and really cool. So let's do that. So a lot of them we use this process called solving right triangles, where we're given one side of the right triangle and what are the angles, and we're asked to find the other side, or we're given two sides and asked to find one of the angles. Okay. Another thing that we use is angle of elevation, which basically represents the angle from the horizontal to an object. So let me show you a picture of what that is. So see here, if I'm down on the ground, let's say I'm standing on the ground and I'm looking up at some object, the angle that my viewpoint makes with the horizontal is called the angle of elevation. Okay, so that's when you're going up, you're looking up, it's elevated. Now, however, if I was like a lifeguard standing on a tower, or if I'm standing on a cliff or something and I'm looking down at the ocean, or I'm looking at a person, the angle that my line of sight makes with the horizontal is it called the angle of depression. Okay, so pretty interesting actually, because they're kind of related. Okay, so let's talk about that. Let's use well, first, before we do that, let's use a trick to solve a right triangle. Okay, so we have here a surveyor standing 115 feet from the base of the Washington Monument. So there's the Washington Monument. Okay, fine. He measures the angle of elevation to the top of the monument to be 78.3 degrees. So how tall is the monument? So basically, so check this out. So we have a right triangle, yeah? We have the distance on the bottom, that's 115 feet from the monument to the little person, okay, or wherever the angle that he's measuring, right? So the actual angle here is 78.3. And then we want to find y, okay? So what trig function connects the opposite side, the opposite side of a right triangle with the adjacent side, okay? And if you said, I'm going to use tangent to solve this one, you're correct. So see, tangent of 78.3 is going to equal opposite over adjacent, and in that case, it would be y over x, where x is 115 and y is the height of the monument. So all you have to do is just basically solve for y, and there you go. Okay, we multiply both sides by x, but x is 115, so we plug that in, and then you just put tangent of 78.3 in your calculator. Make sure that your calculator has degrees in it. Okay, so basically that's it. So by now we need to know, that angle theta is equal to 30 degrees is the angle that satisfies sine of theta is 1/2. But suppose we're given the equation sine of theta is 0.6 and we're supposed to find theta. Okay, so we might kind of guess that sine of theta equaling 0.6, if we know that sine of theta is 0.5 and we know that sine of 45 is 0.7, we could kind of guess that it's in between, right? We could kind of guess that the angle is in between. However, later on, I'm going to show you that there is a function on your calculator, the inverse function. It's very easy to find to solve this problem, okay? Okay, so that's it for 4.3. We have 1 through 15 odd, and then these certain problems. So good luck, and feel free to send me questions, and I will see you on the next video.